Hi guys, welcome. This will be Math 6, 6th grade math, and we're looking at day 5. So again, these will be staggered. You'll be watching this before we meet in class. So you'll have homework from the previous day that you're working on, and then also watching these video recordings that are hopefully not too long. Have those watched, and then we will go over the practice set problems and more examples in class when we meet. So let's go ahead, and today we're looking at lessons 21 through 25. Again, kind of just shortening down these first few units just as a way to kind of review on some of the vocabulary, introduce some new things. Hopefully a lot of it's, multiplication, addition, fractions, and some of these things aren't completely brand new. So let's go ahead and look at lesson 21. We're just going to go through some of the new vocabulary, look at a few examples as needed. Okay. So today, lesson 21 is working with divisibility. So tests for divisibility can help us find the factors of a number. Here we list the divisibility test for the numbers 2, 3, 5, 9, and 10. So all that's saying is there's some tricks or some rules that we can remember as we go through, and we have 3, 4, 5, 6, 7, however large digit numbers. We can look at some of these tricks to see if 2, 3, 5, 9, or 10 go into these values. Now for numbers like 7 or 4 or 8, some of those we're just going to have to actually do the division, but remembering some of these things can help us with some of these numbers to remember, is it divisible or not? Okay, so the first one, 2, if the last digit is even. So it doesn't matter what comes before that. If the last digit, so 342. Okay, well, 2 is an even number. That's the digit in the ones place. So therefore, 2 would go into that number. Doesn't matter what's in the hundreds place or the tens place, thousands, millions, whatever number we're looking at. If it ends in an even number, 2, 4, 6, 8, or 0, okay, then 2 would go into the entire number. So that's a pretty easy one to figure out. 5 is another pretty easy one. If the number ends in 0 or 5, then 5 goes into it. Okay, 5, 10, 15, 20, 25, 30, 35, 40, and continuing on. So if we look at the digit in the ones place, if it's a 0 or a 5, then we know 5 goes into it. So it's divisible by 5, we would say. And then if the last digit is 0, then 10 goes into it. 10, 20, 30, 40, 50, 60, 70, 80, and so on. If it ends in a 0, then we know 10 goes into it. 3 and 9, they're not as simple, but they're still kind of neat. If we remember these, it'll make life a little bit easier. If the sum of the digits is divisible by 3. So let's think of 21. Okay, 21. 2 plus 1 is 3. Well, 3 is divisible by 3, so 3 goes into 21. Let's say 607. Well, 6 plus 0 plus 7 is 13. 3 does not evenly go into 13, so 3 does not go into 607. Okay. Same thing for 9. If they all add up, we add up all the digits, and that sum, that total, is divisible by 9, then the entire number itself is divisible by 9. So 81. 8 plus 1 is 9. 9 goes into 9, so 9 goes into 81. 93, 9 plus 3 is 12. 9 does not evenly go into 12, so it doesn't go into 93. Okay, so those are just some of the tricks that we can look at. Let's see if there's... So if we were to look at this and see if this is divisible by 3, 1179. Here we go. Let's get this working. 11. Oof. 1179. Well, if we add all these together. 1 plus 1 is 2, plus 9 is 11, plus 7 is 18. Well, yeah, 18 divided by 9 is 2. So 9 does go into 18, our total. So it then goes into this entire number. So that's a way that we can, obviously, if we have a calculator or some of our smaller numbers, we just know our multiplication tables, we'll be able to solve it and determine if 3 or 9 or 5 goes into it. But for some of these larger numbers that we probably don't have memorized, this is really helpful to figure out if it has a factor of 3 or 9 or 2 or 4 or whatever. I guess not 4, but 2, 9, 3, 5, or 10, the ones we've talked about. So this one, yes, because we added up all the numbers in the different place values, and then that total was divisible by 9, so 9 goes into that entire number. Okay. 2, 3, 5, 9, and 10. Which of those are factors of 135? Well, we know 5 is because it ends in a 5. 10, it doesn't end in a 0, so we know that's out. 5 is an odd number, not an even number, so it can't be 2. 3, let's test 3. Well, 1 plus 3 is 4, plus 5 is 9. 3 does go into 9, so 3 goes into this entire number. Same thing with 9. 1 plus 3 is 4, plus 5 is 9. 9 goes into 9, so it goes into that entire number. So those are just some rules. Have those written down, or just think about those. We've talked about it already this year, but we'll go back through as we need to, just as we get into reducing fractions, finding greatest common factors and things like that. It'll help to remember some of those rules to see, well, does 2 go into this number? Does 3, 5, 9, 10? Okay, next, lesson 22, looking at equal groups, problems with fractions. So if we look at, fractions, obviously it's just division 1/3, 2/3, 1/4, 3/4. Okay, we can look at those if we know there's equal groups. If we have 12 objects divided into 4 equal groups, and we're going to have 3, 6, 9, and 12, because that's 12 objects divided into 4 groups. So each group is going to have 3. So if we have 2/3 of the 12 musicians played guitar, how many of the musicians played guitar? Okay, well, we have 12 musicians, and we have 2/3, so we have it broken into 3 groups. So 12 divided by 3 is 4. So we're going to have 4, 8, 12. And we look at those 12 musicians broken into 3 groups, 4 musicians each. So 2/3 played guitar and 1/3 did not, obviously. So the 2/3 would be 4 and 4. 4 plus 4 is 8. So 8 musicians played the guitar. So we just have to know what our total is based on the fraction. If it's fifths or fourths or thirds or halves or whatever it is, that'll tell us how many groups we're breaking that number into. Okay, and then we need to make sure 12 divided by 3 is 4. That's where we got 3 was our denominator. That's what we're dividing by. So that tells us the number of groups we have. The total divided by that number, 12 divided by 3, tells us 4 in each group. Okay. 3/4, so we're looking at 4 groups. The total is 28, so 28 divided by 4 is 7. So there's going to be 7 in each group. Okay, so 7, 7, 7, and 7. So 1/4 are not finished. 3/4 are finished. So that would tell us 21, 7 times 3. The problems are finished. 7, which is 1/4 of 28. 7 problems are not finished. Okay. So we have different equal groups just depending on what the fraction is. Okay, that's going to tell us how many groups we're breaking it into, and then our total, if it's percent, that's per 100, so that'd be out of 100. Well, what number, again, this is a word problem, what number is or equals 3/4 of or times 100? And 100 broken into 4 groups is broken into 25, 25, 25, 25. So 3/4 would be 75. So we'll work at this more than one way. We'll be able to multiply 3/4 times 100 to come up with 75. That's the way I would probably do it right off the bat. But again, we can break it into equal groups over here to kind of visualize what's going on with those different groups. Okay. Ratio and rate. Okay, ratio is just when we're comparing two numbers, 13 boys to 15 girls in the classroom. Again, we can write it in words, 13 to 15. We can use this colon in between to say 13 to 15. Kind of looks like time or something. We have that colon in there. More commonly, especially since we'll work on with fractions with probability, fractions just with division, simplifying fractions and things like that. And a ratio, if we're able to simplify, we want to go ahead and do that. So 13/15, 13 to 15, we can't reduce that down at all, so we don't need to reduce that, but we put it in fraction form or one of those three forms, and then that's how we write it. Now, make sure that you read whatever the ratio is. If it said 15 girls to 13 boys, obviously the number of girls and boys hasn't changed, but the ratio then would flip, and the 15 would come before the 15, or it would be in our numerator, and the 13 would be in the denominator. But it said 13 boys and 15 girls, and we're looking for the ratio of boys to girls, so 13 to 15. So it does matter the order that we put the ratios in. If we're comparing boys to girls or girls to boys, that's going to determine, based on whatever we're told here, the order that we need to put the numbers. Okay, and then usually we're comparing two numbers and we have a total. So we have, boys, girls, total number of students, or whatever it is, right-handed baseball players, left-handed baseball players, total number of baseball players, or whatever two things we're comparing. So in example 2, in a class of 28 students, there's 13 boys. What is the ratios of boys to girls? Well, there's 13 boys, there's 28 in total, so we need to find the difference. 28 minus 13 is 15. So it tells us that there's 15 girls. So the ratio of boys 13 to girls 15 would be 13 to 15. And we would just write it as a fraction or in one of those other forms that we showed up above. Okay, so just make sure you read the problem thoroughly, know what two numbers we're comparing in the order that we're comparing them, and then you'll be able to set it up in a ratio. Now, a rate is a ratio of measures. So we're not just talking about inches or feet or minutes or hours or whatever. We're using multiple measurements. Below are some commonly used rates. Notice that per means for each and substitutes for the division sign. So miles per hour, we'll commonly just write it out, 55 miles per hour. Okay, or sometimes we put MPH for a shortened acronym. And we can also write it in fraction form like this: distance over time. For every 1 hour, I'm traveling 55 miles. So that's the rate at which I'm traveling. Mileage, miles per gallon, same thing, but miles over 1 gallon. So we want to reduce it down to where our denominator is 1 hour, 1 gallon, 1 pound, 1 minute, whatever it is that we're talking about. So we don't say 110 miles per 2 hours. That's not technically incorrect, but we want to reduce it down to where we're saying 55 miles per hour. And if your dashboard in your car said 110 miles per 2 hours, then you'd be sitting there doing the math to make sure you weren't speeding. So just do 55 miles per hour. 28 miles per gallon, or a lot of times if you go to the grocery stores, things are sold in a price per pound or per ounce or whatever it is, depending on what we're buying. So the unit price over the quantity, it's $2.89 per pound. And then we'll work on how we can reduce these. Okay, if we're given, a speed, we're traveling 55 miles per hour for 3 hours. How long have we traveled? Well, we'll do some simple math to cancel out the hours, multiply the 55 by 3. Hours over hours would cancel out, and we'd be able to tell you how far we've traveled. Okay, so let's look at example 3. On a bike, Jeremy rode 60 miles in 4 hours. What is his average speed in miles per hour? So 60. Okay, and again, in a word problem, I always just write down what we have: 60 miles in 4 hours. Okay, so our distance was 60 miles, and our time or our duration was 4 hours. Okay, and again, we don't want to know miles per 4 hours. We want to know miles per hour. So we're going to simplify this. Miles and hours aren't going to cancel out because they're two different measurements, but we can simplify 60 over 4. Well, 4 goes into 4 once. It goes into 60 15 times. So 15 miles over our 1 hour. Yeah, or we could just rewrite it as 15 miles per hour. Okay. So we want to simplify that down, okay, to miles per hour, which we did, so we know how fast we were traveling. So you can do this, if you're going on a big family vacation. We got to our destination. We know it was 200 miles away. It took us 3.5 hours to get there. How fast were we traveling? Okay, you can do the math to figure out your average. That doesn't mean you were always traveling that, but that would be your average over the time. Okay, practice set we'll go over. Okay, lesson 24, we're looking at adding and subtracting fractions that have common denominators. So common denominators means that they're over the same number. So like 1/3, if we had for example, 1/3 plus 1/2, these are both real rational numbers. We can add them, but we're going to first need to come up with a common denominator, because I can't just say, well, 1 plus 1 and 3 plus 2. That's not how it works. Thirds and halves are different fractions, so we need to get a common denominator. So we need to think least common multiples. So 3 times 1, 3 times 2, 3 times 3, 3 times 4. So 3, 6, 9, 12. Well, 6, okay, 2, 4, 6, 8, 10, 12. Okay, so 6 was the first number that both of these are factors of. Okay? We want it to be the least. Obviously, 3 and 2 both go into 30, but that's a larger number. We're going to have to then reduce back down at the end, so it'd make more work for ourselves. When we multiply these fractions, we're multiplying it by a fraction that's equivalent to 1. So 3 times 2 is 6. So I'm multiplying top and bottom by 2, because 2 over 2 is still just 1. So we're not changing the value of the fraction. We're just renaming it so that way it has common denominators. And 2 times 3 is 6. So I can't just do the denominator and call this 1/6 and this 1/6. No, 1/3 and 1/6 are not the same value. So I need to multiply top and bottom by the same number. So this becomes 2 over 6, and this becomes 3 over 6. And then when I have those, well, then I just keep the denominator. I don't say 6 plus 6. Okay, that would give us 12ths, which we're not working with. We're working in 6ths. So I just bring that over, and then I add my numerators. 2 plus 3. Okay, 2 plus 3, that's an awful 5, but it would give us 5/6. And then we look to see if there's anything we can do to reduce. In this case, 5 over 6, no common factors, so it's reduced as far as we can go, and we're done. Okay, and then if we have common denominators already, which maybe looks like they're nice to you today. And most of the ones that you'll probably see today already have common denominators, which will make life a little bit easier. If we, down the road, we'll see ones where we have to convert them or rename them. And that's just one extra step that I just showed you. So we can really add any fractions or subtract any fractions. We may just have to manipulate them at the beginning before we add or subtract. So if we look at example 1, 1/4 plus 1/4 plus 1/4, well, 1 plus 1 plus 1 is 3. As we said in the other example, the 4, we don't add those together or multiply them or anything. We just carry that over. Okay, because if we're talking about fourths and I have 1/4, another fourth, I have 2/4, another fourth, I have 3/4. And we can't reduce it down. There we are. Another example here, if I have a half plus 1/2, 2 halves obviously equals a whole, or 1, but 1 plus 1 is 2. 2 over 2, 2 divided by 2 is just 1. So any number over itself, that's true of any number, a negative number, a rational number, any number over itself is just 1, except for 0. 0 is kind of always our rule breaker, but 1 over 1 is 1. 5 over 5 is 1. 25.5 over 25.5 is 1. So any number, if we have the same number in the numerator and denominator, then it just simplifies down to be 1, because 2 goes into 2 one time. So if we take 2 and divide it by 2, we're left with 1. So we just reduce it down. Subtraction. Okay, so if I don't think you'll see any negative fractions today. So usually the larger number will be on the left side here. We'll eventually talk about that down the road, but for now we'll just look at, we have 7/8 minus 2/8. Okay, so the 1/8 is going to be in our answer as our denominator. We may have to reduce, we may not have to. 7 minus 2 is 5, so I'm left with 5/8. Again, not overly difficult once you have common denominators, or if they're already provided in common denominators, then you just do the addition or subtraction in the numerator, and then at the end you look to see if you can simplify. Like the example we looked at earlier, we didn't leave it as 2 halves or 2 over 2, we reduced it down to 1. So if you can reduce, reduce. If there's nothing you can do to reduce it, then you just leave it. All right, practice set we'll go over. I'm looking at, okay. Lesson 25 as well, last little bit of vocab. So writing division answers as mixed numbers. So in the past, you've probably worked with remainders, where if you have something left over when you're dividing, you just write it as a remainder. 5 divided by 3, you have 1 remainder 2. Okay, that's what you've done in the past. Now we're going to write it either as a fraction, like we do in this lesson, or down the road we'll show you how we can do it as a decimal as well. But we're going to leave it as a mixed number. So it'll be a whole number with a fraction instead of writing it as a remainder. We still use that remainder number. We then just put it in a fraction. That will become our numerator over our denominator, whatever we're dividing by. And then also looking at multiples today. So if we have a 15-inch length ribbon, we want to cut into 4 equal lengths. How long would each piece of ribbon be? Okay, well, 15 divided by 4, we know 4, 8, 12, 16, so 12. So 4 goes into 15 3 times, which is 12, so then we have 3 left over. So we don't put remainder 3 over here, we put 3, and then we know that that remainder portion is being divided by 4, so we do 3 and 3/4. Okay, so again, no more remainders, and down the road we'll show you how we can write this as a decimal. It's 3.75, for example. We have some repeating decimals that we'll talk about as well, but for right now we're just going to leave it as a fraction, which means we're going to end up with a mixed number. So we don't write 3. Yes, it does go into it 3 times, but it doesn't go in evenly. It's not, 4 times 3 is not 15, it's 12. So 15 and 12 leaves us a remainder left over with 3, and that's being divided by 4, so that's where we get 3/4. Okay, if we have 25 over 6 is a mixed number, well, 6 goes into 25 4 times, because 4 times 6 is 24, and then I have 1 left over. From 24 to 25, I have 1 left over, and it's being divided by 6 down here. So that tells us Let me highlight. Okay, that tells us what our denominator in our mixed number is going to be. So in the past, you probably just wrote 4 remainder 1. We're just adding a step to that 4 with 1 left over, but that 1 that's left over is being divided by 6. So that's why our fraction is over 6 still. It could go into it evenly. If we had 24 over 6, well, then it would just be 4, because 24 divided by 6 is 4. So we wouldn't put 4 in 0.6 or something like that. We would just say 4. Okay, but if there is a remainder, something left over, we're going to write that as a fraction right there. Hey, multiples, you probably heard that before. You probably done me if you don't remember what the names are for. So multiples of 2, again, 2 times 1, 2 times 2, 3, 4, 5, 6, and continuing on infinitely. But we have 2, 4, 6, 8, 10, 12, 3, 6, 9, 12, 15, 18, 4, 8, 12, 16, 20, 24, and 5. We have 5, 10, 15, 20, 25, 30. Okay? So when you're multiples, you're just multiplying whatever number it is that you have by 1, then 2, then 3, then 4, then 5, or whatever you're being told to do. So the first 4 multiples of 8, we have 8 times 1. It's pretty simple. We always start with the number itself. Okay, so that's 8. Then 8 times 2 is 16. 8 times 3 is 24. And 8 times 4 is 32. And we keep going, but we were only asked to find the first 4 multiples of 8. Okay. And there they are down there. What is the 8th multiple of 7? Again, we can go through our list, but if we know we're just looking for the 8th, well, the first we multiply by 1. The second we multiply by 2. The third we multiply by 3. So we can just say 8 times 7. Well, remember that from our multiplication table. 8 times 7 is 56. So a multiple is multiplication, multiplication. Okay, it's just if we memorize those multiples again, or have it to where we can easily solve for them, it'll help us down the road when we're simplifying fractions or we're looking for least common multiples and things like that for several different numbers. It'll really come in handy. Okay. And there's the practice set for you. We'll be going over that as a class. So again, this will be hopefully watch before we come to class. We'll have it posted. You guys just watch it and come with any questions that you have for the previous homework along with these examples that we went over. Thank you.